16. The sum of three integers in arithmetic progression is 15 and their product is 80. The integers are option A, B, C and D. Now its solution is, let A minus D, A and A plus D be the series, be the three terms which are in IP. It implies since sum is 15, therefore A minus D plus A plus A plus D, which is equal to 15. Now when we add sum of these, it will be 3A equal to 15, which further gives us A equal to 15. Also it is given their product, that means A minus D into A plus D, which is equal to 80. Therefore it will be equal to A into A minus D into A plus D, which is formula, that is A square minus D square, which is equal to 80. Now substituting the values of A, which is 15, this further implies A is 5 here, sorry, because 15 by 3, A is equal to 15 by 3, which is 5. So it implies 5 into 5 square minus D square equal to 80. Now we shift this 5 to the right hand side. It implies 5 square minus D square is equal to 80 divided by 5, which will be equal to 5 square minus D square is equal to 80 divided by 5. 80 divided by 5 is 16. Therefore D square is equal to 25 minus 16. It implies D square equal to 9, which implies D equal to plus minus 3. Therefore A is 5, which is the value of A, and D has two values. Now we will see what will happen with the series. We will find out the two series. So for D equal to 3, then the series is, which is A minus D comma A plus D. Using A equal to 5, the series is 5 minus 3 is 2, then this is further 5, then this is 5 plus 3, that is 8. Therefore the series is 2, 5, 8, or the three numbers are 2, 5, 8. Again for D equal to minus 3, then the series, then A minus D comma A plus D will be since A is 5, for D equal to minus 3, then it will be A is 5 minus 3, that is 8, and it will be 5, then it will be A minus D, A plus D, that is 5 minus 3 is 2. Therefore it has two options. The option C and D are the correct options. Therefore it has two options. It improves. Question number 17. The sum of n terms of an arithmetic progression is 3n square plus 5. the series is. Now we have four options and we are given the nth series, the nth term of the series. Now we have to put simply the values of n since the nth term of series is given. Here the first term, which is s1, which is equal to a1, which is simply equal to now first it is given 3n square plus 5n. So for n we have to substitute. So let us write this sn an, sn simply. So it implies s1 equal to 3 1 square, that is 3 plus 5 into 1, and that is 8. Now s2, which is equal to 3 into 2 square plus 5 into 2, that is 12 plus 10, that is 22. Further s3, which will be equal to 3 into 3 square plus 5 into 3, and this will be equal to 27 plus 15, which is equal to 42. Then we have s4, which is equal to 3 into 4 square plus 5 into 4, which is equal to 68. Therefore option B is the correct option. Question number 18. The number of numbers between 74 and 2556 which is divisible by 5 is. Since we know the first number which will be divisible by 5 is 75, then it will be 80, then 85, and we know the last number divisible by 5 in between these two numbers will be 2555. Therefore it is easy to find the series. The series arising between the given numbers is, we know it will be 75, 80, 85, so on, and the last term of the series will be 25555. Now from this series we know the first term is 75 and the common difference is 5, and here the important point is the last term, which is 25555. Now we have to say how many numbers are these. In other words, we have to say how many terms are these in series. Since we know the last term, we can say let the last term will be an, which is equal to l, that is nth term is l. It implies, now we know the nth term is a plus n minus 1 into d, which is nth term and which is also the last term, because we are saying let n be the number of terms in this series. Since a is 75, we have to find the value of n, so n will be n and d is given by 5, and the last term is 25555. Now it will be equal to n minus 1 into 5 is equal to 2555 5 minus 75. Now we will subtract this number. It implies n minus 5 into 5 is equal to 25480. Then we have to simply transfer this 5, which will be 25480 divided by 5. When we divide this number by 5, it is equal to 5096. That is, n minus 5 is this number. So it will be equal to, sorry, it is 1. N minus 1, n minus 1, n minus 1. It implies n minus 1 is equal to 5096, which implies n equal to 5096 plus 1, which is equal to 5097. Question number 19. The pth term of an AP is 3p minus 1 divided by 6. The sum of first n terms of an AP is. Now we have given 4 options. Since we are given the first only the pth term, from we have to find the nth term. So here the logic is simple. Suppose if I replace p by n, there is no option among the 3. Now we will say, since it is the nth term of an a, n is a plus n minus 1d. So it implies the pth term, which is, I can say AP equal to 3p minus 1 divided by 6. It implies AP is a plus p minus 1d, with a as the first term and d is the common difference, which will be equal to 3p minus 1 divided by 6. Now after multiplying by 6 these terms, it will be 6 into a plus pt minus d is equal to 3p minus 1. Now we will multiply again these terms. It will be equal to 6a plus 6p d minus 6d equal to 3p minus 1. We will compare here d. We will take d as common. Okay, I will write like that. 6 times a minus d. So I will write it here. 6 times a minus d plus 6p times d is equal to 3p minus 1. From here we can observe, on comparing the coefficients of p, we can say on comparing coefficients, when we compare the coefficients, we can say this, the term having p and this term, since on the right hand side and left hand side we have two terms, two terms, and both are same. That implies 6 times a minus d equal to minus 1 and 6 times d equal to 3, because here I will compare the coefficients of p, that is this and this term. 6pd was equal to 3p, it implies 6d equal to 3. When from this 6d equal to 3, it implies d equal to 3 by 6, which is equal to, which implies d equal to 1 by 2. When we have d equal to 1 by 2, using in this term star, it implies 6 times a minus 1 by 2 equal to minus 1. After solving this, we can say a minus 1 by 2 is equal to minus 1 divided by 6. From this, we can say a equal to minus 1 by 6 plus 1 by 2. Therefore, a is equal to 1 by 3. It will imply a equal to 1 by 3. So, a is equal to 1 by 3 and d is equal to 1 by 2. So we have to find the sum of first n terms. Now Sn is equal to n by 2 into 2a plus n minus 1 d, which implies Sn is equal to n by 2 into 2a, that is 2 into 1 by 3, that is 2 by 3, plus n minus 1 and d is 1 by 2. So we will solve these. N by 2, it will be further equal to 2 by 3 plus n by 2 minus 1 by 2. Again, it will be equal to 2 by 3 minus 1 by 2, which will be equal to 2 into 2 is 4 and 3 into 1 is 3 divided by 3 into 2 is 6 plus n by 2, which will further equal to, I will write it here, which will further equal to n by 2 6n divided by 12. Now after that, I will write it like n divided by 2, and I will divide this 2 by, and this I will take 2 common here, like that. So I will write that n divided by 2 into 2 into 1 plus 3n, and I will take this 12 also out, because 2 into 1 is 2 and 2 into 3 is 6, that will be 6n. Then I will cancel this 2 and 2, it will be equal to n by 12 into 1 plus 3n, which is option B. Therefore, option B is the correct option for this one question. Question number 20, which is direct. What is the mean between 33 and 77? Since if we have two numbers a and b, then the arithmetic mean between a and b is given by a plus b divided by 2. Now we are given the numbers 33 and 77. Therefore, arithmetic mean between 33 and 77 is 33 plus 77 divided by 2, which will be equal to 110 divided by 2, which will be equal to 55. Therefore, option C is the correct answer. Number 21. The four arithmetic means between minus 2 and 23 are. Here it is given the first term is minus 2. Then we have to find d, so that we are able to last term, and in addition that we have to find 4 terms, therefore number of terms will be 6, and the last term, which is 23, is given. Now we can say L is equal to A plus n minus 1 D, which is an. And since this time our last term is 23, so we are able to write 2 plus n is 6 minus 1, and D is we have to find out, and this is 23, which implies as n was 6. Now it implies 2 plus 5D equal to 23. Further, it implies 5D equal to 25, which implies D equal to 5. Now we have find out D equal to 5, so we are able to write the arithmetic means. So I will say like that. The first arithmetic mean, if I represent by A1, it will be the first term A plus D, which is equal to minus 2 plus 5, which is equal to 3. Now the second arithmetic mean, if I will write it A2, it will be equal to A1 plus, it will be equal to this first arithmetic mean plus the common difference D, which is 3 plus 5, which is equal to 8. Now the third term, I can say it's 8 plus 5, which is equal to 13. Again, the fourth arithmetic mean will be 13 plus 5, which is 18. Therefore, the four arithmetic means are 3, 8, 13, 18. Therefore, option C is the correct option. Number 22. The first term of an AP is 14, and the sum of the first 5 terms and the first 10 terms are equal in magnitude but opposite in sign. The third term of AP is. Now since the question asks us to find the third term, so we should know A and D. A is given, so we are since sum of 5 terms, that is S5 and S10 are equal but they are opposite in sign, that is this. Sum of first 5 terms is equal to minus of sum of 10 terms. Since we know the formula for Sn is n by 2 into 2a plus n minus 1 d. We will use this formula. This will be equal to, then replace n by 5 on the left hand side, it will be equal to 5 by 2, and then it will be 2 into a is 14, is 28, 2 into 28, then we have plus 4d, it will be equal to minus 10 divided by 2 into is 14. It will be 2 into 14 plus n minus 1, that is 9d. So we can say it will be equal to, now cancel out 2 and 2 because these are in product, and 5 into 2. So it will be equal to 28 plus 4d is equal to minus 2 times, here it is 2, 5. 2 into 28 plus 9d, which will further be equal to 28 plus 4d is equal to minus 56 and minus 18d. Now shifting the constant terms on one side, so it will be equal to 22d is equal to 18 and 4 is 22d. Again, now when we shift 28 here, it will be minus of 28, and sum of this with minus 56, it will sum up minus 84. Here it implies d is equal to minus 84 divided by 22, which is equivalent to 44 4 minus times 42 divided by 11. Now we have to find a3. a3 is equal to a plus n minus 1d, that is a plus 2d. Since first term is 14, and it will be equal to 2 into minus 42 divided by 11, which will be equal to 14 plus 84, so it will be minus of 84 divided by 11. Again, 14 into 11 is 154 minus 84 divided by 11, which will be equivalent to 70 divided by 11. But we have no option in this type. We have a first option, which is mixed form, so we will try to put in this mixed form. 11 into 6 is 66, so I will write 11 into 6 is 66. 66 plus 4 is 70 divided by 11, so option A is the correct option. Number 23. The sum of certain number of terms of an arithmetic progression series minus 8, minus 6, minus 4, so on is 52. The number of terms is, here the first term also given to be 52. Now we know it implies the formula of sum of n terms is n by 2 into 2a plus n minus 1 into d, which is equal to 52. This implies n by 2 into 2 into minus 8 plus n minus 1 d. d is 2, which is equal to 52. Now I will shift this 2 on the right hand side. It will be equal to minus 16 plus 2n minus 2, and here it is n, and it will be equal to 52 into 2. Because this 2 I have transferred it here, so it will be equal to n into 2n minus 18 equal to 104. So it will be equal to 2n square minus 18n, and it will be equal to 104. So I have transferred it here. It will be minus 104 equal to 0. Now this is the quadratic equation. We know to solve the quadratic equation there is a method to solve these types of equations. So it will be like that. First I will take common 2, n square minus 9n, it is here n only, 9n minus 52 equal to 0. Now it implies, since 2 is not equal to 0, it implies n square minus 9n minus 52 equal to 0, which implies n square minus 13n plus 9 plus 4n minus 52 equal to 0, because 13 into 4 is 52. Further it implies n into n minus 13 plus 4 into n minus 13 is equal to 0. This implies either n plus 4 into n minus 13 equal to 0. Here it implies either n plus 4 equal to 0 or n minus 13 equal to 0. From this we know either n is equal to 4 minus 4 or n equal to 13. But n equal to minus 4 is to be rejected or discarded. N cannot be minus 4 because n is a natural number. As n is a natural number, it is as it represents the number of terms. Since number of terms can't be negative, therefore n is equal to 13. Therefore option B is the correct answer. Question number 24. The first and the last term of an AP are minus 4 and 146. The sum of the terms is 7171. The number of terms is here. The first thing it gives us is that the first term is minus 4. Again it says the last term, so we have to find the number of terms here. We will say let these be n terms. It implies then nth term an is equal to 146. So and also it is given sum of n terms is 7171. Here we have to find d. In other way we can say we don't require, we have another formula Sn is equal to n by 2 into a plus l, where a is the first term and l is the last term. This formula is derived from this. Since we know this formula, n by 2 into 2a plus n minus 1d, which is equal to n by 2 into a plus n minus 1d. This is a plus a, this is 2a, so I write instead of a 2a a plus a, and we know it can again be written a plus, since a plus n minus 1d, this is the nth term. For the nth term we have represented the last term l. That is why we can write this formula like that also. It implies then since sum of n terms is 7171, which is equal to n by 2 into a is minus 4 and the last term is 146. This is further equal to 7171 is equal to n by 2 into 142. Now we can divide by this 2, 2 7 is 14 and 2 1. It implies n equal to 7171 and divided by 71, because the 7 will go to divide in the left hand side. Now it will be equal to 71 into 71, that is 1. Further there is 71 into 0, then it will be 71 into 1, that is 717. Therefore option A is the correct option. 25th and last part of this question. It says the sum of the series up to 17 terms. The series is 3 1 by 2 plus 7 plus 10 1 by 2 plus 14. Here the some terms are in mixed form. Here we will see the first term a is 3 1 by 2 which is simply 7 by 2. Now we will check, is this any type of this series. Now a2 minus a1, which is equal to, a2 is 7 minus 7 by 2, which will be equal to 7 into 2 is 14 minus 7 by 2, which is equal to 7 by 2. Now we will check a3 minus a2. This is 21 divided by 2, then it is minus 7. It is 21 minus 14 divided by 2, which is 17, 7 divided by 2. Now we will check a4 minus a3. The term a4 is 14 and this is minus 21 divided by 2, which will again be 28 minus 21, that is 7 divided by 2. Now here we can say a2 minus a1 is equal to a3 minus a2 is equal to a4 minus a3, which is equal to 7 by 2. And we can say the series is in arithmetic progression. So first we have seen the series is in arithmetic progression. Now we are asked sum up to 17 terms. We know if a series is in arithmetic progression, then we can say the number of terms, if it is n, then Sn is equal to n by 2 into 2a plus n minus 1d. But here we are asked some 17 terms, it will be 17 by 2 into 2a. A is 7 by 2 plus n minus 1, that will be 16, and d is 7 by 2. So we can say it is, if you have it will be 17 by 2 into after simplifying this is 63, because then it will be 17 into 63 divided by 2, so it will be equal to which is equal to 71 divided by 2, which is equal to 535.5. So we can write this number by, therefore option C is the correct option. Thanks for watching.